Pinterest has migrated their client application and their front-end edge CDNs to HTTP3. They wrote a blog about it, and there are interesting lesson learned that I want to share with you guys. Let's jump into it. All right, so this comes from Pinterest Engineering Medium blog. Quite an interesting write-up. It's missing some pieces. I don't mind, but I wish they had added those pieces. And I'm going to talk about what are those missing pieces. And there's probably a good reason for that. This article is written by Liam Ma, Scott Beardsley, and Huyen Yan. Now, Pinterest operates on HTTP3. We have enabled HTTP3 for major Pinterest production domains on our multi-CDN edge network. This is a very subtle sentence. Domains. We have enabled HTTP3 on a domain. So be careful with that statement, because certain domains are enabled, certain domains are not. Because you can have a domain point to a CDN, and that domain will map to an IP address, which then tell you after you connect to it and send the first request that, hey, I do support HTTP3 if you're interested. Go ahead and connect to me through HTTP3. Because the default is always almost TCP connection, right? When you go to 443. But how does the client know that this endpoint supports HTTP3? This is something called the alt SVC, and I had a whole podcast discussing just that. Today, we only know after the fact. Right? In HTTP1, we know through a response header called alt service, an actual response header. So we have to actually connect, establish TLS, send the request, and then know that, oh, by the way, there's a quick, or there's HTTP3 endpoint. The faster way is through an HTTP true frame. So you don't really need to send a request. Once you negotiate through ALPN and TLS that you support HTTP2, the server will push a frame to you that's, hey, alt service here. If in case you can just discard this connection and just connect to me through quick. And the faster approach, which is not every client supported, is the SVCB DNS record. As you do a DNS record, give me the A record and the A record for IPv6, and also give me the text record, and also give me the SVCB record, which tells you that, hey, there's an alternative service, HTTP3, during DNS. That's a fast. You can't get any faster than that. Right? And that last part is not really supported. It's a new thing, right? Only Cloudflare, I think, supports it. But clients are lacking behind. Anything with DNS just takes ages to implement. So that's a critical thing here. So they have a multi-CDN edge network. If you don't know what a CDN is, it's a reverse proxy. CDN is just a reverse proxy. Right? You, as a client, connect to the reverse proxy, the CDN, and the CDN turns around and connects to the actual origin backend to fetch information, to fetch the actual data. The CDN can't serve you anything on its own. It has to fetch it from the backend. And the beauty of CDN is caches, is a huge caching layer. It's close to the clients. So if you're coming from India, you resolve the DNS, you're going to get an IP address closest to you. If you're from the US, California, you're going to get an IP address closest to you. And although you're connected to technically the same domain. Magic, I know, right? So you can have multi-CDN, and the CDN will take care of this stuff. And we've upgraded our client's network stack to support new protocol. This allows us to catch up with the industry trends. I hope this is not just a trend and you really know why you're moving, which they do. Most importantly, faster and more reliable networking improves pinners' experience. Is that what you call it? Pinterest? Pinners? really. Like Snapchatter, they call it Snappies, right? Is that TikTokers, YouTubers? I'm a YouTuber, I suppose. Context. Network performance, such as latency and throughput, is critical to Pinner's experience. In 2021, a group of client networking enthusiasts at Pinterest started thinking about adopting HTTP3 or QUIC for Pinterest from traffic CDN to client apps. That's it. They don't talk about their origin backend server. They didn't touch their backend. From what I read this blog twice. They never mentioned their servers. They didn't touch them. They changed the CDN. They technically just enabled the CDN because they're cautious, and I don't blame them for that. Right? They want to try this out with the CDN and their client. So they upgraded their client apps, and they enabled the HTTP3 on the CDN, on some of the CDNs. And they worked through the 2022 and achieved our goal, blah, blah, blah. We're still working towards 2023. Right? How does HTTP3? So they have bullet points of why HTTP3 is good. And I am, if you're not interested in this part, you can skip. But I'm going to take each point and elaborate on why, right? So the first point is no TCP head offline blocking problem in comparison to HTTP2. To explain what is head offline blocking, we're going to understand what does HTTP2 does compared to HTTP1, right? HTTP1 is a simple protocol. It's a request response. You establish a connection and you send a request. And ignoring concurrency and pipelining, you can only send one request on that connection, and you can't send another request on that connection until you receive a response. That connection is marked as busy, right? For reasons I don't want to go through. I talked about many times. Right? Pipelining through proxying is just, it's very hard to do, right? So we said, okay, it's just connection is just HTTP1 is just one connection, one request at a time, right? And that's why Chrome and other browsers open up to 6 per domain. And you can set up to 6 in HTTP 1.1. That's why server-sent events with HTTP 1.1 is really not a good idea if you open many tabs on the same domain, because all of a sudden, because the server-sent event is like one request and then it's an infinite response. That's what it looks like. So to the browser, your connection is in use, so it needs to open another one, up to 6, and then you're done, right? So the 7th will be stalled. You can't even send that 7th request. You can't even browse anything. You can't send anything to the same domain, that is. With HTTP2, they solve this problem and says, okay, let's add some headers. Let's add some metadata to the HTTP protocol at the lower layer, such that we know that, oh, this is request number 1, request number 2, request number 3, and so on. So they added the idea of streams. So you can create odd number streams in the client side, if I'm not mistaken. So 1, 3, 5, 7, and so on. And you can send requests concurrently. Beautiful. And if you send 7 requests, right, the server, let's say the 7th request, the server is so quick. It's a request to get a text file that is tiny, right? Robot.txt or whatever, or fav icon. While the 6 requests are taking long time, the server can immediately respond with the 7th request on stream number, whatever, 13. Right? Do the math. Yeah, so it can respond immediately with that, and it can continue process. So that's the idea of that's the state of the art in the mid 2010s, like 2014, 2015. That's like a big thing, right? Like to HTTP2. Yeah. Problem is with HTTP2, the TCP head offline, because HTTP2 is built on TCP, these 7 requests that you send at the same time, they are sent as stream, one TCP stream. And what is the property of TCP? It's ordered. So if you send request number 1, then request number 2, 3, 4 concurrently. They are kind of labeled with the segment sequence number, right? The sequence plus the length of the TCP data, right? So they are ordered. So what happens if you send all these things, but the server receives only segments 2 to segment 7. Assume 1 segment per request, 1500 bytes MTU, right? So segment 1 was dropped, lost in one of the routers, right? And the server, specifically the kernel TCP IP code, will never deliver the data to the receive buffer for the application to actually read it, because it's not correct. To the TCP, you have missing data. Right? Segment number 1 is missing. So I can't deliver anything after that. That's called TCP head of line blocking. So that means we technically got request number 2 and 3 and 4 and 5 and 6 and 7, and the server can technically process them, but we can't do anything about them, unfortunately. And that's TCP head of line blocking. QUIC solves that by ditching TCP altogether and building everything on top of UDP, and having the idea of streams actually logically grouped and sequenced per stream. So now we're sequencing on the streams, not at the connection level, right? Does that make sense? So if you're sending requests, you're only gonna head of line blocking at the stream level, which is fine, right? Sure, I'm gonna send the same request on the same stream. Just don't do that. Open another stream and send your stuff concurrently. But yeah, that's the state of the art. Plus, QUIC, effectively HTTP3, also combined the connection establishment and the encryption of TLS, which is another thing you had to do, right, into one round trip. So instead of doing it 3-way handshake, then TLS, whether 1.2 or 1.3, you all do that on one step, right? So now, connection migration across IP addresses, which is good for mobile use. So because UDP is connectionless, and QUIC built the idea of having a logical connection, technically, we can enforce the idea of connection at the endpoint. The network doesn't really care if you have a connection or not, because it's a UDP. There is no connection. So what we can do with tricks like that is you can technically change your IP address, because the IP address is no longer an actual header. I suppose it is a header, but it's not really part of the protocol, right? It is, you can change the IP address, but you can tag every datagram that you send with the connection ID, uniquely identifying this connection. So if you're moved from your Wi-Fi to 5G, you left home and all of a sudden your IP address changed, technically QUIC can migrate your connection because you're still sending the same connection ID, right? But your IP address changed. So the server will look up and says, oh, of course there's authentication and stuff like that to migrate the connection. But once you do that, it's like, oh, I trust you. You have the same connection ID, but you came from the different IP address. We're good. So we don't have to reestablish the connection. Pretty cool stuff. Able to change, tune, lost detection and congestion control. Now, because like the congestion control is a feature of TCP at the connection level, QUIC pushed it at the stream level. You can control the traffic for this. Okay, oh, this stream is just I don't know, this video or images. Like, let's be a little bit laxed. It's okay if you have it dropped. Like, sure, one frame or another frame will not be as good, but sure, be a little bit relaxed. Or this is an actual, I don't know, source code that's getting delivered, so we need a better reliability. So of course, reduced connection time. So one round trip, and instead of however many, right, with TCP plus TLS, it depends on the version of TLS, right? And the ability to do also zero RTT, like literally zero RTT, nothing, right? So you can send data with the first request, not first request, first initiation of a connection, right? It's challenging. It's not really easy to do, but you can, right? Zero RTT data. And you can literally just establish if you enable the pre-shared key and session resumption, you can actually do that. So that's really powerful. But even one RTT is awesome, right? more efficient for large payload, as we talked about it, for images. So these advantages, they like this stuff. They want more of it. Let's do it. Strategy. What's their strategy? Safety and metrics came first. Though Pinterest is focused on executing with velocity, it was critical that we took a thoughtful approach to adopting HTTP3. First, we upgraded the client network stacks and created an end-to-end A/B test for each traffic type, image, video. Then we ran extensive experimentation before enabling HTTP3 on both CDNs and clients. So only the clients and the CDNs, that's the only thing that changed. What are the challenges? In order to talk about the challenges, let's read through this. For the web app, some browsers already have HTTP3 or quick support. All browsers almost support HTTP3 now, I think. All right? So now they would favor and they will know how to read this alt service as I talked about, right? And move to that accordingly. So they got to be careful with that. It's like they can't just light up Quick on the server and all of a sudden the browser start using Quick and they have bugs in their code and the apps start break, right? So they have to control that. And they're talking here about the OS version and also Android. But here's the best part. Our CDN vendors are different phases of HTTP3. Some CDN vendor supports, some doesn't. So, and since all of them use almost the same domain, right? They just flip with the domain. Here's the interesting thing. You can do a resolution, get an IP address, connect, and have that domain, that IP address belong to a CDN that supports HTTP3. And so it will return, I don't know, whether an H2 frame or response header, or even if it's sophisticated through the DNS, it will tell you, I support HTTP3, connect to me, turn around and connect to me through a quick connection. Because you got to destroy your connection because it's a different protocol. You can't just use TCP, right? So it turns around and does the quick connection to establish HTTP3. And here's the thing. The DNS time, the TTL, time to live, is short. So what happens if you now turn around and do another DNS, right? And get another IP address, because the TTL has expired. So now you're pointing to another CDN that happened to not support Quick. But guess what? You're still using the same domain. So what is happening here is, at the client side, the client has cached the knowledge that this domain supports Quick and HTTP3, but then it pointed to a different IP that doesn't, and all of a sudden the things break. And that is the most interesting thing I've ever seen. I never thought about this before. Apparently there is a discussion going on with this. So how did they solve this? They solved this by making the DNS TTL very close to the alt service TTL, because even the alt service has a time. Like it trusts this quick, I guess, connection or endpoint for this amount of time. If you make it the same time, they're going to expire at the same time. So the client will learn to ask again, effectively, right? Or do you support or not? And that's basically the most interesting thing here, I think. So they conducted a lot of A/B testing to do that. They added a feature flag in the client side to enable that stuff. Current state, what do they have right now? We have enabled HTTP3 on critical traffic types and upgraded leveraged mobile clients network stacks to utilize HTTP3. Traffic. HTTP3 is enabled on major Pinterest production domains on our multi-CDN edge network. Major, not all of them. Okay? Web will get it for free. All right. If it's a web client, you'll get it for free because it's a browser. iOS, you do an images API traffic will be served through Coronet plus HTTP3, 70%. iOS native stack, you're going to do AV player, and Android is going to do Expo player Coronet. Here's a showcase showing some numbers here. I didn't really understand these diagrams, so I'm not going to go through them, but the interesting thing is really right here. the network request round-trip latency before and after HTTP3. So the round-trip latency here is measured from the client side from request sent to response received, right? Based on 1 week of network layer collected in Q3 with Apple Networking HTTP2 and Q1 with Coronet when HTTP3 was enabled. So they in Q1 2023. So you can see that for those listening, we're looking at, what is this number on the left hand side? What is 2000? What is, okay, around, is it millisecond? That doesn't make any sense. 2000 millisecond, that is really slow. I guess yeah, they're calculating the request itself, right? But still, goddamn slow. What? 5 seconds? I have no idea what this metric is. 5 seconds is really slow, and going down to 3 seconds, that doesn't make it even better. Unless like they gotta include something. It's like, what is it? Am I loading an image? Am I loading a large whatever video? That makes sense if it's like a video, but yeah. So as you can see, guys, here, the future for, let's read the future and discuss a little bit. We will continue to invest in HTTP3 for sustained impact, including increasing HTTP3 coverage, explore other network stacks. So they're still exploring, playing with things, further improving our HTTP3 adoption rate, and experimenting with various congestion control algorithm. Because there is so much to configure here, especially at the stream level with Quick. You do so much things. I'm still learning so much about this stuff. Exploring zero RTT connection standards, because they don't have that right now. Because zero RTT is like something. It's really, first of all, it has danger to enable, and I talked about that in one of my blogs. Replay attacks are a real thing here. I mean, if we're replaying an image, who cares, right? Just read the whole image. But if you're replying an API call that is kind of changing something, and that you send that through zero RTT data, that is dangerous, right? Especially if it's not idempotent, that's a different connection. That's a different story. I mean, but yeah, zero RTT is an interesting thing, especially just send the first request to get something in the same breath as you establish the connection. So to summarize, they moved to HTTP3 only in their CDN and their client. They didn't mention anything about their root backend application at all. Are they gonna, even in the future plan, they didn't talk about like, hey, we're not gonna touch this. Seems like they're staying on HTTP2 on their backend. They're not touching that as far as I know. Reasons, I think they're just playing it safe, to be honest. It's easier to move to the CDNs, because as you cache stuff, your clients will just hit the CDN. So what is the value of moving your backend application so that your CDN can talk in HTTP3 with your backend application? What is the added value there? It's not like the CDN is going to change its IP address, right? It's not like it's going to walk, like it doesn't have legs walking through multiple places and it changes. So the connection migrations doesn't have any value, right? Probably the network between the CDN and the backend application is probably high enough and strong enough that like drops are lower. I can't guarantee that, but could be, right? If that's the case, then HTTP2 is fine, right? Because like even when I say TCP head of line blocking, you gotta think about if the network, that's only happen when your network is weak and you experience frequent drops, which is like in a flaky connection, you know, like a Wi-Fi or a 3G or 5G, or moving from one tower to another tower where like a signal will drop things, right? But in a high bandwidth, what are the chances that this gonna happen? Very low, right? So I'm not sure about that a lot. Even HTTP2, moving from HTTP2 is also something you can question. It's like, and that's what I like about these things. You gotta be pragmatic a little bit. So why should I move? And they probably ask the same question. Why should I upgrade my backend origin? If I don't have to, I'm not gonna do that. HTTP is good enough, right? Okay. Plus the CDN is gonna create one connection to the backend and probably stream everything on that connection. That's it for me today. I thought I'll share this news with you guys. Pinterest moved to HTTP 3. See you in the next one. Goodbye.